Okay, so in this video, I'm going to be going over the statistics module that I didn't get to cover when I canceled class because I wasn't feeling well. So I do apologize about that. But hopefully after this video, we'll be caught up. When we come back, we'll have plenty of time to review for the final. So statistics is a branch of mathematics, a type of mathematics that involves collecting, organizing, and summarizing and presenting data, and then drawing general conclusions from that data. And data, these are measurements or observations that are gathered for an event under study. So whatever you're studying, if you collect the information about your experiment or study, that would be your data. Okay, so when statistical studies are performed, we usually begin by identifying the population for the study, which is the collection of all the subjects under that study. So for example, if I wanted to collect data on how many students at a certain college campus owns pets, then the entire population would consist of everyone that goes to that college, because that is the group that I'm interested in studying. How many people at college have pets? But of course, it's not going to be realistic for me to be able to go and interview or survey everyone that attends a certain college. So we actually take a sample from the population that represents that population. So this is just like a subgroup of the population. So for an example of a sample from a college, I could randomly select 50 people from that college and then ask them, and that 50 people would be my sample. Okay, so there's different types of sampling methods that we can use in order to obtain a representative sample. So the first one is a random sample. And in order to obtain a random sample, each subject of the population must have an equal chance of being selected. So completely random. The second way is a systematic sample. So this is taken by numbering each member of the population and then selecting every kth member, where k is a natural number. And when we use systematic sampling, it's important that the starting number is selected at random. So this would be like if I separated an entire college campus population, like the entire, like let's say I got a directory of all the students that attended this college this year, and I went through the list and selected every 10th person on the list, then that would be an example of a systematic sample. The third example is a stratified sample. And this is when a population is divided into groups where the members of each group have similar characteristics, and members from each group are chosen at random. So this could be dividing the population. We could divide the groups into like each classroom. Like if I went to college campus that day and picked every classroom on campus, that would be dividing the population into groups based on which class they are in, which classroom they are in. And then picking 5 students from each class. So that would be an example of stratified sample. Sorry. And then the fourth type is a cluster sample. And this is when an existing group of subjects that represents the population is used for a sample. So it's kind of just like a subgroup of the population itself. Okay, so we're going to look at an example and identify the different types of sampling that each example is describing. So you'll have questions like this on your module, and they can be pretty confusing. But this one says that a student in an education class is given an assignment to find out how many late typical students at his campus stay up to study. He considered 4 different methods for gathering data. Describe what type of sampling method he's using in each case on the next slide. Then describe whether you think he's likely to get a representative sample. Okay, so he's interested in studying how late students stay up to study. That's what he's interested in studying or learning information about. So that is his experiment that he is conducting. He's going to go ask some students how late they stay up studying. And we want to look at the examples on the next slide and determine what type of sampling method that he is using. And then we're going to decide whether it's a representative sample, which means is it representing the population well. And in this case, his population would be probably from his college. They haven't really specifically said that, but we'll see. Because he's in a student in an education class. And yeah, so he's wanting to know how late typical students at his campus. So the students at his campus would be the population. Okay. So the first type of sampling he is doing for A is he stops by the Union before his 9 a.m. class and asks everyone sitting at a table how late they were up studying the night before. So he's just walking into the school before his 9 a.m. class. He stops by the Union, and then he asks everyone sitting at a table how late they were studying the night before. So let's go back and look at our 4 types of sampling methods. So in order to obtain a random sample, each subject of the population must have an equal chance of being selected. So it would not be a random sample because he is going and he's only going into one certain building and asking all the people sitting at the table, I think is what they said. Yeah. And so those people, they have a higher chance of being selected as a participant in this survey because he's walking to class and it's a building on his way to class. So they have a higher chance of being selected, and then he selects everyone at that table. So it's not a random sample, and it's not representative either because he's asking people how late they stay up to study right before his 9 a.m. class. This is early. So those people probably didn't stay up late to study. The next one is a systematic sample. So by numbering each member of the population. Well, we didn't do that. The entire population are the number of students on his campus. So this was just him going into a building and selecting a group sitting at a table. So that's not numbering the population. So it's not number 2. 3 is when a population is divided into subgroups where the members of each group have similar characteristics and members from each group are chosen at random. Well, he didn't divide the population into groups. He just went into one building and picked a table. And then 4 is when an existing group of subjects that represents the population is used for a sample. So this would actually be this type of method, cluster sample, because it's just an existing group of subjects that represents the population. They're an existing group because they're just grouped together in that union building and sitting at the same table. B says he asks the school registrar to give him a list of 50 students whose student ID numbers end in 4. Okay. So you might think at first that this is the systematic sample, because it sounds like they're numbering each member by selecting the kth member. But this is a random list of 50 students. And the list, well, it's not completely like chosen at random. They chose it based on the student ID number ends in 4. So it's not every kth member, it's just a list of 50 students whose student ID numbers end in 4. And so it wouldn't be the numbering the kth member. So this is actually going to be a random sample. Because the student IDs ending in number 4, that is pretty random. Right? Even if they went in order, like the student ID numbers of each person that came into school got a student ID, if they were numbered in order, then choosing the one that ends in 4, this would be, not exactly in the order that students came and got their student ID. So it is random. This is completely random. And then C is that they survey the 5 people sitting closest to the door in each of his 5 classes. So this one is going to be a stratified sample. Because if we go back to the definition, a stratified sample is whenever a population is divided into groups where the members of each group have similar characteristics and members from each group are chosen at random. So for this one, he is surveying the 5 people sitting closest to the door in each of his 5 classes. So he's picking 5 different groups, which is his 5 different classes, and then picking people from each group randomly because they're just sitting closest to the door. And then finally, D says, look at the campus directory and choose the first name at the top of each page. So this would be the systematic sampling, because they are choosing the kth member from the campus directory. So look at the campus directory and choose the first name at the top of each page. So this would be the kth member of the population. Okay, so there are 2 main branches of statistics, descriptive and inferential. So descriptive statistics is when statistical techniques are used to describe data. And this is based on collecting, organizing, and reporting data without using the data to draw any wide-ranging conclusions. So it's really just collecting data and then organizing, but you're not really making any conclusions about the data, just collecting it. So for example, a researcher might be interested in the average age of the full-time students on your campus and how many credit hours they're scheduled for this term. So he might just be interested, in that information. But statistical techniques that are used to make inferences are called inferential statistics. So this is based on studying characteristics of a sample within a larger population and using them to draw conclusions about the entire population. So you're actually making conclusions about the data that you're collecting. So for example, the Bureau of Labor and Statistics estimates the number of people in the United States that are unemployed every month. And since it would be impossible to survey everyone, the Bureau picks a sample of adults to see what percentage are unemployed. Then they use that information to estimate the unemployment rate for the entire population. Okay, so they actually use that information to estimate the employment or unemployment rate for the entire population. So they actually made an inference about it, about the data. Okay, so when we collect this data, it is called the raw data. Whenever we just collect it, this is the raw data. But in order to describe situations and draw conclusions, we need to organize the data in a meaningful way. And there's two methods that we'll be focusing on in this module on how to organize raw data, and that is using frequency distributions and stem and leaf plots. So we're going to be talking about both of those. The first type of frequency distribution we will investigate is the categorical frequency distribution. So this is used when the data are categorical rather than numerical. So when it's not numbers. So that's what we're going to do in this example. So this example says that 25 volunteers for a medical research study were given a blood test to obtain their blood types. The data follows. Construct a frequency distribution for the data. So this is our raw data. This is all the types of blood types from the 25 volunteers. Now this would be our sample for our study, the 25 volunteers. And this, again, is the raw data here. These are all the blood types. The blood types that there are is type A, type B, type O, and type AB. So there's 25 listed blood types in this raw data, and we're going to create a frequency distribution for the data on the next slide. So we're going to take this raw data, and we are going to organize it into a frequency distribution. So here is one type of a frequency distribution. So they have the possible types of blood type listed on the left, A, B, O, and AB. So that's all the different types in our raw data that we see. And frequency means how many times does it occur. So we're going to go through our data here and count how many times each blood type occurs. So for example, for A, I have one A here, so I can put a tally mark there. I have one A here, so that's another tally. Another one there, that's another tally mark. Another one there, that's another tally mark. And one more there, so that's 5. So the frequency is actually going to be the number 5. The tally is kind of just for us to count how many is in there. And then for B, there's 1, 2, 3, 4, 5, 6, 7. So that's 7 tallies, and the number 7 will go in the frequency. So we're just counting how many of each type to get this complete version of this frequency distribution table here. Okay, so this would be the complete frequency distribution table. All right, now another type of frequency distribution that can be constructed uses numerical data, and this is called grouped frequency distribution. In a grouped frequency distribution, the numerical data are divided into classes. So these classes are kind of like the types that we've seen in the categorical data for the blood types. So the types that we had here, and we could actually count how many of each type were in our data. Well, for numbers, if we have numbers in our data, we're going to separate the types into classes, which is like a range of numbers. A range or an interval of numbers. That's what classes are. So for example, if you gather data on the weights of people in your class, there's a decent chance that no two people have the same exact weight. So it would be reasonable to group people into weight ranges, like people that weigh between 100 and 119 pounds, and then 120 to 139 pounds, and so forth. So these would be the classes for our data frequency distribution. So sometimes you have to pick the classes yourself. So here is some tips in order to do that. So when we're deciding on classes for a grouped frequency distribution, the first thing we want to do is try to keep the number of classes between 5 and 15. So the number of like categories, types, the number of ranges. And then the second one is to make sure the classes do not overlap. And the third is don't leave out any numbers between the lowest and the highest, even if nothing falls into a particular class. And 4, make sure the range of numbers included in a class is the same for each one, which means the length. Range means length of your interval of numbers. And then 5 says the beginning and ending values have to be chosen based on how the data values are rounded. So if I started one at 10, I would want to start the next one at 20. So this would go from 10 to 19, 20 to 29, 30 to 39. But I could also do like 10 to 14, and then 15 to 19, and then 20 to 24. So that would be lengths of 4. Or 5, sorry. Okay. So in this example, we're going to take this data that is numerical and organize it into a frequency distribution. So this will represent the record high temperatures for each of the 50 states in degrees Fahrenheit. So they want us to construct a group frequency distribution for the data. So in order to do this from hand, without being told what our classes are or anything, here is a step-by-step process on how to figure out your classes. So the first step is to subtract the lowest value from the highest value. So if we look in this data, The 134 is the highest value, and the 100 is the lowest value in this data. So these, because these are temperatures, right? So all of these recorded temperatures in Fahrenheit ranges between 100 and 134 degrees. So, because these are the record high temperatures, so they're really high. So the first thing we're going to do is find the range of our data, and that is found by taking the largest value and subtracting the smallest value. What this does is it gives us the range of our values so that we can get an idea of how many classes to separate our numbers into. So that's what step 2 is. If we use a range of 5 degrees, meaning like the classes would go from 100 to 104 degrees, because that's 5, including the 100, that is one number, 101, 102, 103, 104. So that's 5 numbers. That will give us 7 classes, because if I divide 34 by 5, it's about 6.8. So it's not the only choice, but it's a good choice to keep it with a small amount of classes and a small range for each class. Okay, so step 3 is, so we're going to use a range of 5 degrees, and we're going to have 7 classes. So step 3 is to start with the lowest value and add 5 to get the lower class limits. So these are the lower class limits, and I'm going to show you what that means on the next slide. Okay, so here is our class. I start with 100, that's the lowest. I want this to have a range of 5. So if I add 5 to 100, that will give me 105, and that will be the lower limit of my next class. So here, this is the lower limit of the first class, and 104 is the higher limit of the first class. So it includes the numbers 100, 101, 102, 103, and 104, which is 5 digits, or 5 numbers. Then the next class is from 105 to 109, and then 110 to 114, 115 to 119, 120 to 124, 125 to 129, and 130 to 134. So now we've created our classes, and you do see that there is 7. 1, 2, 3, 4, 5, 6, 7. So 7 classes with 5 numbers in each class. Now we can set up our frequency distribution. So just like with the categories of the blood types, we put the classes or the types here on the left-hand side of our table. And then we tally how many fall into each category. So I look for all the numbers that are either 100 through 104. So I have 100, another 100. I have another one, 104 right there. So that is 3. So you see the 3 tally marks and the number 3 here. And then the numbers 105 through 109. I have 106, 109, 105, 109, 106, 107, one more, 105. So that's 1, 2, 3, 4, 5, 6, 7, and there's actually one more, 108. So that is 8. Just making sure. I think there was a typo on here earlier, but don't think that was it. Okay, so that's the 8, because 8 fell in between that range. And then you keep going for all the rest. And I am going to pause the video here because I have someone outside of my office, and then I'll probably just make another video to finish.